So hi, today I'm going to talk about the lead code question 239 sliding window maximum. So what this question asks us is if there is a given array nums, for example 1, 3, -1, -3, and a window size of 3, we have to find the maximum of all possible windows. The first window is starting from minimum the window size. For example, here the number of elements, suppose n. So the first window is starting from the third element because the window size is 3. So there will be total n minus k windows, which we like for which we which we need to compute the maximum for. So for example, in this window the maximum is 3, so answer is 3. In this window also 3, in this window 5, and consecutively. So what we can do is the easiest solution is like to iterate over the array one by one. For example, we can start from the first index and then end at the third index and calculate the maximum for this window, then push back into the answer array. Then for the second, uh, till the fourth, then from third till the sixth, and consecutively. But it would take a time complexity of the number of windows, that is n minus k, into window size of each. So each loop will be also running for the window size, that is k. So n minus k into k, but we want a better time complexity. So what we can do is implement a sliding window type approach to get a better time complexity and solve it in one go or n time. So what I the best approach that I can think of is using a monotonic queue along with a double-ended queue, so that we could track of indexes on and track of the start. We can keep track of the start of the queue and the end of the queue at the same time. So I'm going to define a double-ended queue, DQ, with the integer type. Then I am going to give the answer require the question requires to give an answer in vector end. So I'm going to define a final answer array. Then I'm going to start iterating. For int I is equals to 0, I less than n. So n here is the size of the array nums. So n is equals to nums dot size. So I plus plus, iterating over the array. Then what I need to do, the first step is check whether the number actually exists in the current window. So if the number like if the double-ended queue is not currently empty, first we need to check that before any operations. And the element is still in the double-ended queue, that is dq dot front. The frontmost index is still in I I minus k. That is the current index minus the window size. If front is less than equal to this, then we what we need to do is dq dot pop front. The second condition we need to check here is if dq is not empty, and dq uh, dot sorry, not dq dot write, actually nums dot current dq's back. That is, we are implementing a monotonic decreasing queue. So we only need to keep the best element, that is the front, and we can remove the all the new element which are lesser than that. So sorry. Also here we need to use a while loop. We need to do for all the elements in the DQ, only not only for the first one. So while here also, so nums dot dq dot back is lesser than nums dot I. We need to do dq dot pop underscore back. Okay. So what we now need to do is dq dot push the current element into the queue, that is the ith element. And then what we need to do is initially no then what we need to do is push back into the final answer array. To do that, we don't need to calculate from the start. We need to calculate only for the n minus k windows. So the ith index, the current index, should at least be greater than k minus 1. Then only we are going to push answer dot push underscore back dq, uh, sorry, not dq, nums dot dq dot front. The front element is the greatest element, so we only need to push back that only. So now we could simply return the answer. Let, let's check if it's working fine. So there is an error. Okay. The expected output says 3 comma 3 5 comma 1. Okay, so I think I did an error here. Let's check now. Yeah, now it's working fine. Let's submit it and test if it working fine for all the test cases. Yeah, it is working fine. So now the time complexity is reduced from the n minus k into k, that is approximately uh, n square in n into k, uh, to n, except the uh, search memory is now the memory uh, is a dq, that is k elements at the time. So there's an extra memory of k. The answer we already need to return, so I will not count for that. And yeah, I think that's it. Thank you.